Okay, in this problem, we have an overall delta H, so we're going to be solving for a piece in here. We're going to basically be looking for the number off this chart. Okay, and we may end up seeing it on the chart, we might not. Either way, we have to still go through the work to prove that we know how we got it. So we're still going to set this up as products minus reactants. So 1 times C2 Cl4 liquid plus 4 times H2O liquid. So that's my products. Minus 1 times C2H4 gas plus 4 times HCl gas, that's some nasty stuff, plus 2 times O2 gas. Okay, so this is what we're looking for. This becomes our X. So where is it? It's right here. Could be anywhere, but this happens to be right in front. So 1 times X plus 4 times liquid water. So go find liquid water. By the way, water is the one that often gets easily copied incorrectly. Every once in a while they throw a gaseous water at you and you have to do the 241.8. So just be really careful that with water especially, because I see that as a common mistake, you're grabbing the correct state of matter for water. In this case, 285.8. So this is going to be negative 285.8 minus 1 times C2H4, right? Now remember where we find hydrocarbons. They're in the very back of this stack. So if you have it printed off, you're just going to flip to the back. Otherwise, C2H4 gas, C2H4 5226, C2H4 gas, yeah, 52, I already forgot, I'm old, sorry, 5226. So that's going to be 1 times 52.26, and it's a positive, plus 4 times gaseous hydrochloric acid. Okay, so we're looking for the H's again. HCl gas is negative 9231. So that's going to be 4 times negative 9231. I said that in my head several times and I still want to make sure. Okay. Plus, now oxygen is normally a gas at standard conditions, so that's going to be times 0. Okay. Now, remember that this whole thing was set equal to this value, right? So I really should have set this equal to that. So now we're going to take our X, and we're going to figure out what this is. So 4 times negative 285, and you don't have to show all this. You need to show me this part, and then I don't really care how much of the rest of the math you show. But I'm going to go through it so you can see the math and what I'm doing here. So that is X, right? 1 times X is X, and X is X. Blech. Okay, we got negative 1143.2 there, minus, and then I'm going to figure out what these two pieces are. This is 52.26 plus 4 times 92.31 negative. This is going to be negative 369.24 plus 0. So all I did was the math inside these pieces. Remember that this is all equal to the negative 878.5. Because this whole thing we knew the delta H value for. So now we're going to say X plus negative 1143.2. Again, I'm showing way more work than you may want to show. 52.26 plus 369.24 negative. So then this equals negative 316.98 equals negative 878.5. Remember where I got this from was the delta H, because we knew this overall reaction at a delta H value of that. We're solving for an unknown, right? So this would be a number that we would have on our yellow sheet. Okay, our thermodynamic table, which I copied in yellow most years. Okay, you may be just verifying this number. Either way, you have to show the work. You can't just write the number off the yellow sheet or the thermodynamic sheet. To get credit, you have to show the work. Okay, so then this is going to be X. And if I take 1143.2, negative 1143.2 minus 316.98 negative, I get negative 826.22 equals negative 878.5. I'm solving for X, so that means I'm going to add this to both sides. So X equals, okay, 878.5 negative plus 820, Let me try that again, 826.22, and I get a negative 52.28 kilojoules for my X value. Okay, and I agree with that number from years past. Just want to make sure I didn't do anything funky. Oops, that's not a kJ. I don't want to make that look like a kilojoule. That's kilogram. This is kilojoules per mole. Okay, so I just solved for X. So we can either solve for something inside of our products minus reactants if we have the overall, or the other kinds of problems are we are solving for the overall delta H.